Basic matrix operations is today's topic. So basic matrix operations today. So if we're going to talk about basic matrix operations, we should probably learn what a matrix is. Okay? A matrix, oh no, there it goes, is a rectangular arrangement of numbers that are organized into rows and columns. Okay? So, what's up?
I just looking at you.
Oh, yeah, I know.
Teacher.
Yeah, I know. I just seen you. I thought you were writing this down, and then you're like, oh. You're giving me the, oh. Okay. Okay. So it's a rectangular arrangement of numbers organized into rows and columns. Okay. Matrices are named using capital letters. Okay. So if we're talking about a particular matrix, we would be talking about that particular matrix capital letter. So we would refer to it as matrix A or matrix P, okay? However we want. The individual numbers that make up the rows and columns, those are each individually called an element. Okay? So an element of a matrix is an individual number somewhere in the arrangement. This is an example of a matrix. Okay. This particular matrix has 2 rows and 3 columns, which means it has 6 elements. Okay. Each row and column intersection has to be filled by an element. You can't have a gap in one in a matrix. Each element will be filled with a number. Okay. Matrices and the different sizes of matrices have dimensions. Okay. And so we look at the size of a matrix first. Okay. And the size of the matrix is given by its dimensions. And dimensions are always rows by columns. Okay? So everything that you need to know about matrices is rows by columns. Okay? Addresses are given rows by columns. Size are rows by columns. When we get to multiplying matrices next week, Wednesday, we'll be talking about rows by columns and how we have to do that and everything like that. Everything, sorry, take your chair. Everything deals with rows by columns. Okay? Each individual element has an address, and that address is the row that it's in and the column that it's in. So for instance, 3 in matrix A, the number 3, or the element 3, if you will, would have the address of A11, and that signifies that it's in matrix A, row 1, column 1. -5 would have an address of A23. It's in matrix A, and within matrix A, it's in row 2, column 3. And so on and so forth. Okay. So those are matrices. Okay. Today, what we want to talk about is we want to talk about the basic matrix operations that there are. Okay? There are 3 basic operations, and there is 1, or 2, I should say, advanced operations. Okay? The 3 basic operations are adding, subtracting, and scalar multiplication. We'll deal with those today. The two more involved, the two advanced operations are matrix multiplication, where we multiply a matrix by another matrix, and inverses. And we'll get to those on Wednesday of next week. Okay. So, with addition and subtraction, the very first thing that you have to check is that do the matrices have equal dimensions? If they do have equal dimensions, you can add or subtract them. If they don't have equal dimensions, you're done. They cannot be added or subtracted. And I'll say that again for emphasis. Okay? What? What? Did I put the emphasis on the wrong syllable?
Oh.
Get it? Okay. Alright. So, they have to be the same dimensions. So your first check is row by column, 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 with however many matrices that you're adding or subtracting together. Okay. So the first check is, well, this first matrix has 2 rows and 2 columns, so it is a 2 by 2 matrix. Second matrix has 2 rows, 2 columns. It is a 2 by 2 matrix. So those are the exact same size because they have the exact same dimensions. They are able to be added and subtracted together. Okay? In this particular case, we are adding them together. So what we do then to add them together is we take the corresponding elements and they get added or subtracted. Okay? So in this particular case, let me see if I got some, so yeah, I do have a little bit of space here. Okay? So in this particular case, I would have 4 plus 2 as my first element. I would have 0 plus 7 as my second element. I'd have negative 6 plus negative 1 as my third element, and I'd have 2 plus negative 5 as my fourth element. Then I just simply do that math. 4 plus 2 is 6. 0 plus 7 is 7. Negative 6 plus negative 1 is negative 7. 2 plus negative 5 is negative 3. Now, one thing that we haven't talked about yet is we haven't talked about how to read matrices. Okay? So this is a matrix. Its size is 2 by 2. So if I were communicating to you, I'd want to give you as much information as I could about the matrix. So the very first thing I would communicate is I would communicate the size of the matrix. So I would say the result is a 2 by 2 matrix. Okay? So now in my brain I know I've got 2 rows and 2 columns. Okay? And then I would read left to right, top to bottom, and I would pause after each row. Okay? So if I were telling you this as an answer and you were checking it, if you will, I would say the result is a 2 by 2 matrix, 6, 7, negative 7, negative 3. Okay? Left to right, top to bottom, pause a little bit after each row. Okay? Or say, first row is 6, 7. Second row is negative 7, negative 3. You want to be as clear as you can to the recipient of your information. Okay? Try that one. I get the 2 by 2 matrix, because both are 2 by 2 matrices, so I can do this. I get the 2 by 2 matrix of 6, -5, 12, -8. Yes? No? Maybe. I have no idea where it came from. But we're going to go take this wonderful young little spider, and we're going to go take him out in the hallway. Hopefully I make it before he crawls up my arm again. Be free, child. Be free. What? Because I don't want it to rain. What? No, it's an old wives' tale. If you kill a spider, it's going to rain. Okay. Find the necessary value of x and y to make this matrix equation true. Okay. So you got to kind of look at the different elements. It's telling you that you can add those two matrices together. Okay. Telling you that. Okay. Which we could, because it's a 2 by 2 and a 2 by 2. It equals out a 2 by 2. All is good there. So this first thing is telling me then, if I've got a matrix equation, the corresponding elements have to be equal to each other. What I mean by that is -2 plus -3 has to equal -5. So this one plus this one has to equal that one. And -2 plus -3 is -5. Okay, so that's good so far. Then I would say that this one plus this one has to equal this one. So that tells me that y is equal to 7. If y is 7, we have a true statement. Then this one plus this one has to equal this one. So x plus 7 has to equal -2. So that tells me what? X equals -9. If x is equal to -9, we have a true statement. Then, I'll go in a different color here. This one plus this one has to equal this one. -5 plus 4 has to equal -1, and -5 plus 4 is -1. Okay. So the two answers then that we would have been looking for here would have been x equals -9 and y equals 7. Okay. Scalar multiplication is the third of the basic operations. Scalar multiplication is multiplying a matrix by a real number. Okay. Think of the distributive property here. Hopefully Corey didn't step on the spider when he left. Usually, just as a side note, on these windows, usually in the spring when it warms up a little bit, you get some big, ginormous spiders. Like this one right up here. But you get ones bigger than that.
Like that one on the wall?
I don't think that's a spider. That's just a piece of, like, that's just kind of like a piece of weed. or something like that.
Oh, I see.
Good job. But yeah, one year they were ginormous. They were like, honking thing. Outside though, so it's okay. Yeah, not warm enough yet. Okay? So if I'm scalar multiplying here, I'm going to take this negative 3 value and I'm going to multiply it there, 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 and there. I'm going to multiply it into all of the elements of that particular matrix. Okay? So my result here then would be negative 3 times 3 is negative 9. Negative 3 times negative 2 is positive 6. Negative 3 times positive 1 is negative 3. Negative 3 times negative 10 is positive 30. So my resultant matrix is a 2 by 2 matrix of negative 9, 6, negative 3, 30. We can combine the adding and the subtracting of the matrices by simply saying, all right, well, so here's this one. Well, again, first I got to make sure that I have the same dimensions. 2 by 2 on the first one, 2 by 2 on the second one, so I can add them. If I don't have the exact same dimensions, can't add them, done with the problem. Not possible would be the answer. If I can't do something in matrices, the answer is not possible because it's physically impossible to do. Okay? But here on this one, what I'd first do is I'd first distribute in that 4, and so that would be 8, 12, negative 4, and 20 as the 4 elements of my 2 by 2 matrix. Then I would go about subtracting off the second matrix. And I'd get, so the first element would be 8 minus 6, well that's 2. Second element would be 12 minus negative 4, well that's 16. Third element would be negative 4 minus 1, well that's negative 5. And the last element would be 20 minus 15, or excuse me, 20 minus 5, and that's 15. So that's my result. 2 by 2 matrix of 2, 16, negative 5, 15. Okay? Like you to do now is calculate that resultant matrix. So if I distribute in the 1/4 first, I get 2. And then I get negative 3, I get 0, and I get 1 for my first matrix. 2 by 2 matrix of 2, negative 3, 0, 1. If I distribute the 2 in here, I get negative 6, 14, 2, and negative 4 as my second 2 by 2 matrix. Those can be added together because they are the same size. I get negative 4, 11, 2, and negative 3 as my result. 2 by 2 matrix result, negative 4, 11, 2, negative 3. Okay? What I'd like you to do now is I'd like you to find me values of x and y that make that matrix equation true. While you do that, I'll go check on Fred. See if Fred's still alive. Fred's gone. Yeah.
So now the people on the other side of the recording think we killed somebody, but he escaped.
He did escape. or he's currently on the bottom of Corey's shoe. One of the two. Negative 3 plus 3 has to be x. I get x has got to be 0. Zero plus 9 is 9. 6 plus negative 7 is negative 1. That all checks out. And then we've got 3/4 y plus negative 4 equals 5. So that's 3/4 y equals 9. So that's 12. Judging by the fact that you've all packed up, I guess we're done.